Hello everyone, thank you for joining in. Today we'll be going over the second video of the series where we explore and talk about networks and communications. Hopefully this will give you some glimpse and useful info about the subject. So let's begin and get started. Alright, so now we're going to be talking about what is a network core. So a network core is an essential part of the internet that connects and routes data between major networks and devices worldwide. It's made up of high-speed routers, fiber optic cables, and large-scale data centers that ensure information can move efficiently from one end of the world to another. So now when we go on to the purpose of it, so the purpose of network core is to transfer data quickly and reliably across long distances. It doesn't deal directly with end users. Instead, it focuses on moving packets of information between different parts of the network through packet switching, where data is broken into small chunks and sent through the fastest available routes. So next with things like routing, we have the network uses advanced routers and switches to direct data alongside the most efficient paths. These devices constantly analyze network traffic and make split-end decisions to avoid congestions and reduce delays, ensuring that the information reaches its destination quickly. Next was scalability and reliability. So the core is designed to handle massive amounts of data and adapt as the network grows. So through redundancy, multiple paths, and fault-tolerant architecture, the network core keeps the internet running smoothly even if individual components fail. Alright, so now we're going to be going on packet and circuits. So data in the network core can travel in two primary ways, packet switching or circuit switching. These are methods of moving information from one point to another, each optimized for different types of network traffic. So with packet switching, we have things like data is broken into small units called packets, each traveling independently through the network. So this method is efficient and flexible because packets can take different routes to avoid congestion, making it ideal for the internet and most modern like networks, just so it can avoid it and it can avoid all the issues with it. Next we have things like circuit switching. So circuit switching establishes a dedicated path between the sender and the receiver for the entire duration of a session. While it's less flexible than the packet switching, it guarantees a continuous predictable connection. It's historically been used in traditional telephone networks, and the differences between each of these is that packet switching will prioritize efficiency and adaptability, allowing networks to handle bursts of data from multiple users simultaneously. Circuit switching prioritizes stability and reserved bandwidth, which is useful for applications that require uninterrupted service. Okay, so our next topic is about switching. So network switching is the process of directing data from one device to another within a network. It happens at the network or data link and layers, and it determines the best path for data to reach its destination efficiently. So switching ensures that local and wide area networks can operate smoothly even under the heavy traffic it can go through. So the different types of switching is that there usually is three main types. We have, as we discussed in the previous slide, circuit switching, packet switching, and then message switching. So the circuit switching reserves a dedicated path, packet switching sends data in small packets, and then message switching temporarily stores the entire message at intermediate nodes before forwarding them. So with switching devices, you have devices like the network switches and routers that manage the movement of data. The switches work within local networks to connect multiple devices, while the routers themselves connect different networks and guide packets across larger infrastructures. And so with efficiency and management of it, switching helps avoid congestion and ensures bandwidth is used effectively. So some techniques are like store and forward and cut through switching. These allow the networks to minimize delays and also maximize performance. Alright, so now we're going to be talking about the internet structure. So the internet structure is a massive network of networks organized in layers and hierarchies to manage data efficiently. Its structure connects millions of devices, service providers, and data centers around the world, allowing information to flow reliably from one point to another. So in terms of the organization, the internet is structured into two tiers with the backbone networks at the top, regional networks in the middle, and the local networks at the bottom. This hierarchy manages to help traffic, reduce congestion, and ensures data can travel long distances efficiently. Next, we have things like systems. So the networks are grouped into autonomous systems, which are independently managed networks with their own routing policies. They communicate through standard protocols like border gateway, and they also ensure that the data reaches the correct destination across multiple networks. And then for redundancy and reliability, we have things like The internet structure includes multiple pathways for the data, so if one route fails, traffic can then be rerouted automatically. This redundancy is crucial for maintaining continuous connectivity and minimizing the risk of outages. Alright, so next we're going to be talking about performance, which includes things like loss, delay, and throughput. So network performance measures how effectively and reliably data moves across the network. So these critical metrics like loss, delay, and throughput help engineers evaluate and optimize network behavior. And it helps ensure users experience fast and dependable connections. So with loss, it occurs when packets fail to reach their destination, often due to congestion, hardware failures, or signal interference. Minimizing the loss is essential for applications like video streaming or online gaming, where missing information can disrupt the performance of it. With things like delay, it measures the time it takes for data to travel from the source to the destination, so factors like distance, routing, complexity, and processing at intermediate nodes can contribute to the delay. With things like throughput is basically like the rate at which data is successfully delivered over the network, usually measured in bits per second. Higher throughput indicates better capacity and efficiency, allowing networks to handle more traffic without slowing down. Alright, and with that, we are at the end. Thank you for watching. I hope that this helps and was of use to you. And please feel free to like, comment, share, and subscribe. Thank you, and I will see you in the next video.